Y'all may well have me quoting Karl Marx or something. I'm going to do that, right? All right, listen. Listen. Here's a graph. Hey, ladies. Y'all on YouTube stars now. All right. YouTube math stars. Here we go. Graph of the sequence Q. Define Q for the nth term. Listen. Where did the dot start for? This is our number of terms in. This is the value of the sequence. So what's n for the first term here? The value is -3. But what's n when the value is -3? N is 1. So I'm going to n and q of n here. How about that? And when n is 2, what's q of n? 0. When n is 3, q. And when n is 4. And when n is 5. So what's happening here? We got q of 1 equals -3, and we're doing what each time? Adding 3, right? We're asked to find an nth term definition, an equation for the nth term for q of n. Let's go back to what we had just a minute ago. We were doing an arithmetic sequence earlier where it was adding each time, and we wanted an nth term definition. Are we starting with n equals 1, or are we starting with n equals 0? So we're going to use this rule, so y'all help me. Do q of n. Yes, sir. Y'all, this is how I describe this. Painless. That's exactly right. I've had jobs where I felt pain, but doing math wasn't one of them, right? Painless. Number 12. A sequence is defined by f of 0, we're starting with 0, equals 3. F of n equals 2 times f of n minus 1. What kind of sequence we got here? This one's a geometric because we're multiplying each term, right? Says we're going to write a definition for the nth term. Now, seems like I told y'all, for the nth term, if we start with 0, a of n equals your first term times your common ratio raised to the n power. Do what?
You're running too small. You're running like ant size.
I only got so much paper. I only got so much paper.
I can only see things. I see N plus H. Nope. Yep, I do.
Nth.
Oh. See? Sorry.
That's all right. I'll tell you what it says. Yes.
Is it a of n equals a of 1 or 0?
When we start with n equals 0, the first term's a of 0. When we start with n equals 1, it would be a of 1.
A of N equals A.
I'm going to write that bigger up here. Look here. If we start with n equals 0. For a geometric sequence,
You said you were going to write it bigger. For real.
a of n equals
I like the one you wrote on the board.
a of 0. I know, but I can't record it on the board. Times the common ratio raised to the n power.
So times R.
Yes, raised to the n power.
Would it be different if it was a of 1?
If n equals 1 is the first term. This is what you're asking about, Houston. That means a of 1 is the first term, right? All right? Then we're going to do a of n equals a of 1, the first term, times the common ratio raised to the n minus 1. Yes, the R is the common ratio. So we got to write a definition for the nth term. Are we starting with n equals 1 or 0? Look here. So we're going to say f of n equals what?
3 times 2 to the n power.
That's it. That's it. That's how we do it. We got time for one more on this video. We got a geometric sequence. Starts with 20, 60. Ask us to define recursively and for the nth term. What's happening? If we're going from 20 to 60, how are we getting there in a geometric sequence? Multiplying by 3, right? So that means our R is 3. And recursively, if we're going to do a geometric sequence, A of n equals R times A of n minus 1. So what is this sequence G of n going to look like recursively? Go ahead, Houston.
Would it be g of n equals g parentheses n minus 1 times 3?
Or you could say 3 times G of n minus 1, right? Either way, that's fine. Either way. You just multiply the previous term by 3. Every time. That's a 7-minute video. I'm going to stop it there, and we're going to do 14 and 15 on the next videos.